Now, I'm going to host three colleagues of mine. They are part of the Simulia R&D product management team. We will discuss how to accelerate innovation through platform. And so, with me, Carl Kurs, okay, Srinivas Tadapeli, and Gregor Judex. Okay, guys?
All right, thanks.
I give you the stage.
Thank you. Thank you, Eric, and welcome everyone to our session on accelerating innovation with the 3D Experience platform. And the theme of this presentation is really about science and science's discovering. So I wanted to start by asking the question, how do we discover? How do we innovate? And we saw in Dr. Faray's presentation yesterday in the keynote that we have a lot to thank the medical sciences for in terms of really laying the groundwork for how science really works in terms of how we start with the questions, develop ideas, and then test theories in order to improve our understanding of our products or how things work, and then importantly to share those results and have peer reviews and so on to understand and get a better know-how from how that testing has worked. And so really it comes down to, in my opinion, really to three key things. We constantly ask questions of ourselves and try to answer those. So we're asking, how can we develop better products? Can I make it lighter? Can I use less resources? Can I make it more efficiently? Can I make it safer? We then run tests, and simulation allows us to run numerous tests, many more than the physical tests that we could perform. And this is really about acquiring knowledge, acquiring data points that allow us to explore our products and explore the world around us and to explain it. And as Dr. Fay concluded there, we really need to go beyond the simulation result or beyond the test result to develop the understanding of what that test means and what that result means, and to be able to really extract the value from that. And so we'll be looking at that in some detail in this session. Of course, at Dassault Systems, we really pride ourselves on providing our customers with the capability of realistic simulation to realistically simulate your products and how your products behave, how those products interact with the natural environment, and of course, what makes us tick and how we function. And what I like about these examples is that they've been coupled with realistic rendering to really change the language that we're communicating simulation results in. As Dr. Pipes mentioned yesterday, if simulation is to be the language of the future, then these new techniques to how we articulate that simulation through augmented reality or through realistic rendering help us. They're the Babelfish, or they're the Google Translate or the Bing Translate, to help us communicate that to a wider audience and the value of realistic simulation. So what we're going to talk about in the next 45 minutes or so, my colleagues and I, are really how the 3D Experience platform helps to accelerate the innovation process, helps you to improve that process and become more efficient in the scientific method that we've been using throughout the years. I'm going to start with the core platform services and how they help you to work more efficiently with your data and with the tools that you use. I'll then hand over to my colleague Srinivas Tadapali, who will use the example of brake system engineering and how providing solutions on the cloud help to empower engineers to give them access to flexible resources in terms of simulation tools and hardware to perform that process. And finally, my colleague Gregor will talk about an example using the concept body engineering and showing how we bring design and simulation closer together to provide provide more simulations earlier in the design process. Okay, So what I'm going to show now is really the core services, or some of the core services of the 3D Experience platform, and explain how these help you in your day-to-day activities. The first thing I'm going to show is the 3D search and 6W tags capability, and this is really driving to help us extract more of the know-how from the data that we're creating from simulation. I'll then talk about our 3D Swim application, and again, this is changing the way we're working with our data and communicating our data on our simulation data, making this more collaborative and readily available. And finally, I'll talk about our 3D dashboard application, which is really helping engineers focus on their day-to-day tasks by providing them access to all of the data that they're using and all of their tools that they're using in a consistent environment to make that more efficient for them to use. So let me start by explaining a little bit about our 3D search and 6W tags capability. At its heart, the 3D search capability is allowing you to take your information and retrieve that information using key attributes, who created it, when it was created, how it was created and why, and so on. So we can search for your data and retrieve it very efficiently. But the 6W tags helps us to filter that, to find specific data. And on top of that, we're helping by providing in-context analytics. We can help you understand more about the data that you're storing, how many types of data, what the current status of the data is, so you can start to understand more about the engineering data that you're creating. So here I have an example of this in action. This is the 3D Experience application. I'm logged in and I can see all of the engineering communities that I'm a member of. And this could be, depending on the number of projects that are active at this time, quite a lot of information. I'm using the 6W tags to help me really filter that information to find some specific data that I'm interested in. I can search by who created it, and as I said, these in-context analytics allow me to understand and provide some additional information to deep dive that capability to understand the amount of data associated with a project or a specific work piece to see what has been created as part of this work. And finally, I can use custom tags to show specific attributes, such as all of the posts related to simulation results in this particular case. So how can we use this capability to get more information about the knowledge? We're running lots of simulations, but how do we extract more value from that? And I'm going to use the example of the Abacus input file, which will be familiar to most of you, but it could be an electromagnetics case, it could be a fluid dynamics case. It's completely interchangeable. And at its heart, the Abacus input file is essentially a route to an engineering result, a piece of knowledge that helps us understand a product better or how a product's going to behave. And then from that, we would hope to draw some engineering decisions based on that knowledge. But in fact, embedded in the creation of that input file and what we then do with it, there's an awful lot of intellectual property that goes into that. And this is what we're referring to as the know-how behind that simulation. What are the material properties? Are they validated material properties? What is the appropriate mesh density for this simulation type? And so on and so forth. And this is all typically locked inside the input file. There's additional attributes such as how the simulation was executed, how many cores, what hardware was required, and also critically, what the simulation outcomes were. What we typically find when we're archiving this information or when we're storing this information is that our customers are storing the input file plus the simulation report. So an awful lot of that know-how, that key information, that IP that we're using and entering into the input file is lost and moving forward. So what we did as an activity is to see how the platform could be used to really extract this information as we're building it. And so I used a process composer activity to really manage the process which we use to store Abacus files. And when we run this process, effectively the Abacus input file is parsed, and we extract some key attributes out of that to make it more readily searchable and retrievable to get more of the know-how from that file. I can then deploy that process as a web application so that all of my colleagues with access to the 3D Experience platform can upload their Abacus files in exactly the same way. And finally, the result of this is we have a searchable database on the 3D Experience platform, which is accessible to 6W tags and 3D searching, which allows me then to very quickly filter based on key attributes of the data to extract the know-how out of that input file. Which solver was used, how many Abacus steps were used, which project directory, any number of attributes we can extract, and then use the 6W tag services to really retrieve that data in the future. Of course, you will have heard over the course of this event that we have been in the process of releasing a lot of Power BI applications where we're helping to extract the value of the 3D Experience platform using our simulation tools such as Abacus and CST Studio Suite and so on and so forth. The next application I'd like to talk about is 3D Swim. Now 3D Swim is our social and collaboration application. I said at the start that we hadn't really changed the way we innovate too much. And over the last probably 20 years, we've been hooked on emails for our primary source of communication. I think we can all agree that emails is not necessarily the most efficient way to communicate on a project task. So can we use a more social collaboration tools to communicate directly on the data that we're creating and collaborate with our colleagues? And then once we do it in that way, we can use our 6W tagging capability to search and retrieve the data more efficiently. Finally, I'd like to talk about our 3D dashboard application, which provides our users the capability to bring all of their key information and tools within easy access. So you could take all your support requests and all of the support tools that you use and make those accessible through the dashboard. We can access all of your online documentation, bring that into an interface which is consistent, access to all of your engineering data for your projects, and also the simulation tools. We can make all of that available within a single interface, accessible for your engineers. So let's see how that works. Here we have the 3D dashboard application. I can see in the top right-hand corner here all of my project tasks. And associated with those tasks, all of the engineering data, I can link directly to the tasks. I can share those tasks with my colleagues. One of the nice things about the 3D dashboard is that all of the widgets are interoperable, so I can drag and drop specific data, in this case some design data, between the interactive widgets on the browser, and in this case I can explore my 3D product to understand more about the system, the 3D design that I'm working on. So in this case, I have my brake disc assembly, and I can use my browser application to review key information about that. So again, now I'm using 6W tagging to understand more about that data. I can color code and filter based on who owns the data, who's responsible for that, the current life cycle state. And so again, I'm getting a deeper understanding of what the data is and how it needs to be used and what actions need to be taken. I can then take that further through my design data, through additional widgets, and look at comparisons between different designs. So here I'm taking that same brake disc assembly, and the 3D Experience platform will automatically associate that with other similar design points, and I can then do a detailed comparison between those design points, again through the browser. You can see here I can scroll through all the different levels of the assembly, and then within the interface I can see in a color code plot the differences, the different vane configurations, the different thickness configurations, and I can understand now what I may need to resimulate to understand how that change is affecting affecting me. I can collect all of the simulation tools that I want to run. So here I can see the Abacus study application, which Srinivas will show in some more detail. And I can monitor the jobs as I'm submitting them. So here I'm accessing all of the tools. Quite critically, I can also share the simulation results in lightweight applications. So here we can see 3D structural simulation results in a lightweight player, multi-body dynamic simulation results, and electromagnetic simulation results, all consistently shown. And I can share this project information very quickly with my colleagues, again using this lightweight application through a browser. So it's really online, it's accessible to all the people associated in the project. And one of the nice benefits is this: if for anyone like me who spent hours creating PowerPoint reports or documents and creating many 2D plots and pasting those into a report, the 3D Play really helps us to avoid that by providing all of those tools in 3D. I can also access our collaborative tools for decision support, and Gregor and Srinivas will both show this in their sessions. Finally, I can access all of my, share all of this key information with my project team. So the interactive collaborative tasks allow me to assign tasks associated with the key data with my colleagues very quickly in order to share that information and make sure everyone is aligned and working efficiently. So some of the key takeaways before I hand over to Srinivas. I've shown how the 3D Experience platform helps us to leverage your IP by maintaining and storing key information. I've shown how we try to encourage collaboration, changing the way we're communicating on our design and simulation data. And finally, I've shown how the 3D dashboard helps your engineers to focus on engineering by providing a cockpit for all of their engineering tools and data. And with that, I'd like to hand over to Srinivas to talk about the cloud applications.
Thank you, Carl. So today, for this part of the presentation, I'm going to put myself in the shoes of a small, medium business company or a tier 1 supplier whose primary business is developing best-in-class automotive braking systems. As you all can appreciate, this is quite a challenging problem, and simulation is quite widely used when it comes to designing these brake system engineering processes. Now, simulation itself has got its own challenges, and a lot of our customers, when it comes to performing these simulations, they face a number of challenges on a day-to-day basis. So let's take a look at some of these challenges. Firstly, we're not just doing one simulation, but in fact, we want to do hundreds of simulations, thereby designing and looking at a number of design points or design variables. And oftentimes, when you run these hundreds of simulations, the pressure is on the analysts so that they have to produce these simulation results much faster, thereby the turnaround time needs to be decreased. Analysts are also using not just one tool, but pretty much all the simulation tools at their disposal. So there is a need to access more and more simulation tools as and when needed. Oftentimes, it's not just us working within a small organization, but you need the ability to collaborate with an OEM who has in fact asked you to come up with this brake system process. And lastly, particularly when I'm a small company or a tier 1 supplier, I need the ability to rapidly expand both my software as well as my hardware resources as and when I need. I need to have the flexibility to quickly expand. So to address some of these challenges, today we'll be specifically talking about two different solutions. The first one is Abacus Powered By. Earlier, Carl talked about what exactly Powered By is. In a way, in summary, Powered By is a way that we are enabling you all to bring in your standalone products onto the 3D Experience platform. And that's exactly what we'll be demonstrating today. And also, we will talk about how you can in fact take this entire brake system engineering process and perform this end-to-end on the 3D Experience platform, thereby breaking down the silos between different departments, such as upstream thinking, design, engineering, and manufacturing. So let's get started with the first one, which is the Abacus Powered by the 3D Experience platform on the cloud. As Carl mentioned earlier, we first start with a dashboard. A dashboard is a web-based application where you can pretty much access all the tools at your disposal. I start off with the collaborative tasks application where I can see all the tasks that have been assigned to me either within my organization or by the OEM to the supplier. All the files that are required or associated for this particular task can be attached right in here. The next step is for me to go to the Compass and select the Abacus Study application. Abacus Study is a cloud-first or a cloud-native application, meaning zero installation required. You can pretty much run your simulations, all the structural simulations, in a browser. So once I instantiate this application, the first step for a user is to go ahead and create what we call as a project space by giving it a name and providing a brief description in terms of what we'll be performing. And once you say OK, a project folder is being instantiated for the user in the background. The next step is to go ahead and upload your input files or your Abacus modal files. This can be typically coming from your preprocessor such as Abacus CAE or any third-party preprocessor. There's no limitation. This can be sitting on your local file system where you can quickly search and upload, or if it is already on the 3D Experience platform, you can use the 3D search and the 6W tags that Carl talked about earlier and quickly instantiate that in your simulation. All the user next needs to do is select that you want to run on the 3D Experience cloud platform. And then you quickly select the number of cores in the terms of the performance metric or the slider that you want. That's about it. These are some of the basic attributes that you need to pick and choose. At this point, when you hit run, you will see that your Abacus job is being submitted on the cloud right away without any delay. This is one of the unique advantages of the 3D Experience cloud. There's really no wait time or queue time. Every time you submit a job, we ensure that it starts right away. And these are all the typical output files that you see if you were to run your job locally. You can monitor the status of your job, take a look at the progress. You can look at all the typical Abacus output files, your status file, your message file, your DAT file, so on and so forth, as you would do if you were to run this locally on premises. It takes a few minutes for me to run this job on up to 32 cores. And then once the job is complete, a lightweight results object is automatically created for the user. We in fact detect, based on the type of simulation you run, we extract all the necessary important information and create a results object for you. As seen earlier, we can now use the simulation review application by accessing that from the Compass. Again, Simulation Review is a cloud-first or a cloud-native application where you can quickly access and do some lightweight post-processing of your structural analysis results. One of the unique capabilities of the Simulation Review application is it doesn't matter where you are on the planet. Once you have access to the 3D Experience platform on the cloud, without copying or downloading or moving your data back and forth, you can share these results, in fact, from the Simulation Review application to all the stakeholders who have access to the 3D Experience platform. In this case, what you're looking at is the contact pressure as well as the one-minus stresses and the displacements for this particular brake squeal analysis. As said earlier, all you need to do is find the user within your organization or, in fact, with the OEM who has asked you to perform the simulation, and then simply click share. On the receiving end, they just get a link. When they click that on, they can log in into the platform and look at the exact same results as you were looking at a second ago. So all this is great. What you have seen so far is very quickly, within 10 minutes, you can access to the 3D Experience platform cloud and be able to run your structural simulations powered by the 3D Experience platform on the cloud. But the challenge still remains, that is, a lot of these tasks have been done in silos, where your upstream thinking is done by one team, your design and engineering is done by one team, and then the manufacturing is done by the other team. Instead, let's take a look at how you can perform all these tasks in parallel or in series on the 3D Experience platform, powered by the cloud. Firstly, we can start off with the problem identification, where you're trying to get all the necessary geometric details, material properties, and so on. And then we can use the best-in-class rules-based meshing and automated modeling tools to create a very high-quality mesh, followed by creating these different scenario attributes so that you're simulating your brake squeal analysis as realistically as possible. But oftentimes, you're not just running one simulation, as said earlier. You want to perform a sensitivity analysis or a design of experiments where you're running hundreds of simulations. And then finally, we'll talk about the results analytics, which is also a cloud-based application where you can then assimilate all the simulation data and make meaningful decisions. So let's see what the first few steps are here. Again, we start off with the modeling tools available on the 3D Experience platform. This is the geometry of a brake assembly. All the different parts have been accommodated here. We have used rules-based meshing as well as the automated modeling to create a very high-quality mesh based on the best practices. We have also assigned section properties and material properties all automatically for this subsystem. The next step is to go ahead and create all your typical abacus scenarios where you're applying your contact pressure, you're imposing your frictional coefficient, extracting the natural frequencies as well as the complex frequencies. And then, of course, you can run the simulation on the cloud. You don't have to worry about making sure you have the necessary infrastructure on premises. Once you run the simulation, it takes a few minutes to run. And then, of course, you can use the high-performance visualization technology to look at a detailed post-processing to identify the particular brake squeal mode in this case, which might causing you the problem, which in fact will then be used to go back and change some design points. Now that we have run these baseline simulations, the next step for us is to really use the process composer technology that Carl briefly talked about earlier and see how we can capture this entire process so that we are running a design of experiments or a sensitivity analysis, all native to the 3D Experience platform. One of the unique benefits of using this process composer technology is, firstly, it provides a single environment for all my model, scenario, and results. Well, you might argue, if I use these standalone products? In fact, earlier in Dr. Fay's presentation, she has talked about using different disparate tools in conjunction with EyeSight. And typically, this is how a process looks like. But if you were to use all these applications natively on the platform, you can really shrink it down because a lot of these capabilities can be accessed directly within these attributes. As seen here, on the left, what you're seeing here is my entire CAE model and a part of my model tree, where I can quickly access my entire model attributes. On to the right you're seeing is the process capture technology, where I can directly access the exact same parts of my model tree. Similarly, for the scenario, and finally, for the results. Because I can directly access to all these different attributes in my model tree, you don't have to import and export all these things between different tools. Now that you have captured this process, the next step is to go ahead and create a sensitivity analysis or a design of experiments and then deploy this process within the organization. Here, I can use a DOE adapter within the process composer technology. A number of optimization tools are available. For this example, we are using Aladdin Hypercube method with about 50 points so that it automatically generates all these outputs as well as the factors that you have included in your DOE. By picking all these attributes, it directly populates you the entire design matrix that you will be using in order to run these design of experiments. And then, of course, when it comes to the output, specifically for this particular workflow, I'm interested in monitoring my brake squeal modes that I want to avoid, as well as some contact pressures that are of my interest. Once you capture this process, the next step is to go ahead and run this process. You can run all these simultaneously. The next step is, now that all my simulations have been run, I want to be able to use some collaborative decision support tools that are available on the platform so that I can make meaningful decisions. To do that, we'll be using the results analytics application. Again, as said earlier, this is a cloud-first or a cloud-native application, zero installation required. You can access this in a browser to explore your entire design space and be able to recommend the best designs. So the way we do that is, again, within the results analytics application, once you instantiate that, you first start off with your process that you have captured. And now the users get the ability to define all the attributes. You can pick and choose all the variables that you're trying to minimize or maximize. Once you get all the attributes, the next step is it automatically ranks all these 50 design points that we simulated based on the attributes that you have chosen earlier. At any point, users can pick and choose a specific design point and understand what are those attributes that are affecting the results. Users also have the ability to be able to predict what is going to happen. And lastly, within the results analytics technology itself, you have the ability to collaborate as well as communicate your results either with folks within your organization or outside your organization. So in summary, some of the key takeaways for this particular section are, firstly, we started off with our 3D experience platform on the cloud offer. What you're seeing here is the best-in-class cloud offer that we are offering to our customers. As opposed to other vendors, we are a one-stop shop. You get access to infrastructure as a service, platform as a service, which is the entire 3D experience platform, and all the core capabilities that Carl talked about. And lastly, you can access your best-in-class applications, be it either for structures or fluids or electromagnetics or other technologies that we are developing as a software as a service on the cloud. With the 3D experience simulation on the cloud, we are also offering our customers the ability to capture their peak workloads in the form of burst computing. So whenever you have these peak simulation requirements, you can easily access those on the cloud and thereby continue your simulation workflows. And lastly, cloud brings you all a number of advantages, starting with accessibility to on-demand software and hardware, thereby improving your overall IT efficiency, particularly when it comes to your on-premises workflows. Cloud fosters and improves collaboration, and ultimately all these advantages will help you all bring your products faster to market. Now that you have seen how we are empowering engineers by using 3D experience simulation on the cloud, I am now going to introduce my colleague Gregor Udex, who will talk about how you can supercharge simulation all the way from conceptual phase to the detailed design. Thank you.
Thank you, Srinivas. So Srinivas was showing us how 3D experience can empower engineering on a sub-assembly level. Now I want to enhance the scope to full vehicle level. And allow me one remark before I start off. As you see, I'm talking about an automotive example, but even if you're working in any other industry, I'm very confident that you can easily translate all the different technologies and techniques that I will describe to your business workflows as well. So this is the sequence in a typical concept body engineering process. Before I go through the details here, let me talk a little bit about the challenges here. The first one is change. Change is intrinsic to the concept phase, and maybe to every development phase. So we have to provide a technique, a process that we can easily update our simulation model whenever the geometry has changed. Secondly, safety. Safety is the most important requirement in modern cars. We want to make sure that we achieve a 5-star rating with our new product. So we have to include crash analysis very early in the design process. And the third one is MDO, multidisciplinary design optimization. So we need techniques to being able to play with the different parameters, with the geometric parameters as well as with the simulation attributes to find out the sensitivity on the different disciplines that we will solve. So my goal of what I want to show you is how 3D experience can help you to speed up such a process when multiple engineers focusing on multiple disciplines are working together. And actually this is achieved by bringing the design engineer and the simulation engineer closer together, by bringing them onto one platform. So let me now go through that process here. The first step will be to define the requirements. And we can, of course, manage those requirements within 3D experience, and they will be the basis for our styling, and then to create the body in white of our structure, which will be done in step number 2. Step number 3 is we want to enrich the structure, because as I said before, our goal is to run a realistic crash analysis. So we have to add additional components that add mass and stiffness to our body in white. And this is what we do in that step. And then we set up all the different scenarios, which is actually done by different people within our company. So there's one group who's responsible to create the stiffness scenario, another one who creates the NVH scenario, and another one who finishes with the crash scenario. So then we can run these different scenarios within 3D experience and use high performance visualization to visualize those results within 3D experience. So we now ran through that process once. The next step would be that we play with the different parameters. We want to get some ideas of how the sensitivities are. So in step number 6, we will set up a process to run hundreds of models with a design of experiment, to do a trade-off study, and then use results analytics similar to what Srinivas was showing before to validate those results from that process. Okay, so now let's go through that in a little bit more detail. Let's assume we already created the requirements. We already built our styling. So the next step is we create our body in white. And for that, I'm using a specific technology we own, which is called SFE Concept. The beauty about that technology is that we can create global design variables, which allow us to modify the overall dimensions of our structure. So, for example, we can modify the wheelbase of our car, or we can change the roof height of our car. Now, in the next step, we want to enrich our structure. But in that early stage, maybe not all the different components of the new car are already available. So what we can do is we simply reuse components from previous car programs. And since we are reusing those components, we can also reuse the existing mesh, because within 3D experience we do store the geometry and the mesh together, so that when we add the geometry to our body in white, we are also adding the mesh at the same time. Now let's see how this looks like. Here we loaded already the body in white. We are now searching for our corner modules. We get about 80 hits, and we can narrow them down by 6W tagging. And I'm using a specific tag here to very quickly find the component of interest. I'm opening it now in the right-hand side tab. You see it's a simplified component with a very coarse mesh, but it should be good enough for our early evaluation here. Now, we can add that structure by saying insert existing component and then click on the right-hand side tab here to add that subassembly to our body in white. And in the same way, we can add additional components like the wheels, the right-hand side suspension, and also a placeholder for the electric powertrain, which should mimic mass and stiffness for that structure. So these are all the components here that we actually want to add to our structure, and which are now the basis for our crash analysis that we can perform. In the next step, we are setting up all the different scenarios. As I said before, different groups within the company will work on that. And actually what we do is we run a crash scenario. We run two kind of stiffness scenarios, a bending and a torsion scenario, and we also calculate the eigenfrequencies of the body in white. So this is done by different people, but due to full traceability on the platform, it's very easy to find all these results later on within 3D experience. And I'll show you how this works. Here we are exploring our product. We can now go into business intelligence essentials, on the sub-item simulation will show with a highlighting in the tree for which components results are available. And we see that for the root assembly, we do have result for the frontal crash. And then if we further scroll down the list, you see that for the body in white, we calculated 3 different scenarios, which is the torsion, the bending, and the NVH result. From that view, we can directly open those models. We can directly access the results. So here you see in the upper left-hand side corner the result for the bending of the body in white. Down here, the torsion test results. On the right-hand side, NVH, and the upper right-hand side corner, the crash results. Let's have a deeper look on the crash results. What we ran here is the full frontal crash according to the US NCAP. The requirement here is that the maximum acceleration at the seating position is 35 g. So let's check the history output. And we see that the maximum for our accelerations is exactly at 35 g. So we did meet our requirements already with our concept car here. Now, at that stage, we ran through the process once, and our management may ask us, what's the actual status? How are we doing with our concept car? And I don't know how you would answer that question today. Maybe you create a PowerPoint and send it out via email. Now, the beauty about the platform is you can use a live dashboard and share it with your colleagues. So a live dashboard means that it would update as soon as new results are available, and everybody is looking at the same dashboard, at the single source of truth. We started from the requirements. So here on the left-hand side, this is the list of our requirements, and we want to check our results against those requirements. In the middle column, this is all our test executions. In our case, it's all the different abacus analysis that we ran. And then on the right-hand side, it's the validation status. So let's look at some details here. So for example, that's the side impole impact. We didn't run that analysis until now. So that's why we are on yellow, not validated. The first row shows the full frontal crash. And we did see that we met the requirements, so we are on green here. While we still have some troubles with our eigenfrequencies. So it's here we have the status validation failed. Which leads me directly into the next topic, because now we have to change something. And if you think about a change scenario with the tools you're using today, you have to go back to the geometry, change something, and often this is a lot of manual work to update your simulation scenarios then. And here 3D experience can really play to its full strengths, because we do have full associativity. And this, what I mean here is the associativity between the geometry, the mesh, and the different scenarios, the different analysis cases that we ran. So that if you go back and change the geometry, you can automatically update your mesh, and you can automatically update all the different scenarios, and immediately rerun them. In particular, you could go in and change some of the global SFE design variables. So you could play with the roof height or with the wheelbase, as I've shown you before. You could also modify any of the geometry parameters. You could also, of course, tweak any of the simulation attributes, like the shell thickness of some of the sheet metals. And last but not least, you could, of course, also replace some of the components. So let me show you one example here. As you remember, we added some components before to add mass and stiffness to make a realistic crash scenario, but these were just placeholders for the final components, which in the meantime have been developed by our colleagues. So we want to replace them. These are the more refined components that have been created. They already got meshed by our colleagues. So now let's load our original assembly here on the left-hand side and the sub-assembly on the right-hand side. And now we can go in and say replace by existing and point to the other to the left-hand side tab, and by that replace one sub-assembly by the other. And when we replace that, we also replace the original mesh, because as I said before, geometry and mesh are stored together. But it may not only be one mesh, it could be multiple meshes which are stored with one geometry. So the only additional step that we have to take is now select which of those meshes we want to use for our crash analysis. Because maybe you want to use a different one in crash and another one for your NVH analysis. So that's what we do here in the contributing FemRep menu. The only last step is now to do the automatic update. To automatically update all the connections that we created between our components and the frame structure. And you will see if I zoom in now, you will see that these have been properly updated. Here we see the ones between the lower arm and the frame structure. And of course, all those connections got properly updated, and we can immediately now rerun our crash scenario. Now that we've seen that we have access to all these parameters and can play with them, similar to what Srinivas was doing before with the brake system, we can now create a trade-off study where we, within the design of experiment, we modify some of those parameters, geometric parameters, as well as simulation attributes, and then in parallel rerun all the different scenarios that we created, which are associative to the original one here. And then we can at the same time write out performance attributes like comfort, durability, and safety, which we'll use to validate our design. Now, if we run such a process, we will get hundreds of results, which we then can validate with results analytics. And the results analytics app is actually available within a dashboard, meaning within a browser interface, so that you can also very easily share those results then with your colleague. And here I want to show you how we compare two specific results that we created for this particular analysis here. So we can go in here and compare specific results like the XY plot for the accelerations. We could also compare animations here in that case from the crash analysis of the two variants. Then in another tab, you could compare the different attributes like comfort, durability, and safety. And then in the collaboration view, you could go in and change priorities. Previously, we said safety is very important. So now we could go in and increase the priority for safety. And by that, the ranking may change. And we ultimately find that alternative 17 is the one with the highest score that meets our requirements in the best way. Now, what I've been showing you is how 3D Experience can speed up a process where multiple engineers focusing on different disciplines are working closely together. And 3D Experience empowers change scenarios due to the full associativity that we provide, and which also allows you to do multidisciplinary optimization. And previously, Srinivas was showing you how to use process apps to do sensitivity studies. And these process apps could also be used to democratize your simulations and share them with your colleagues. And he demonstrated his example using the cloud, which would give you very quick and easy access to our latest technologies. And at the beginning, Carl was talking about how to manage data on the platform, but not only data, in particular also know-how and intellectual property. And this will help you to streamline your collaboration and communication within your company. With that, I want to thank you for your attention. I hope you liked our presentation, and I'm looking forward to meeting you during the rest of the conference, and in particular during today's evening event in the aquarium. Thank you.
Thank you.